This has to be the most interesting and elegant thing I've ever made. It's a solar motor. I got the idea of building it from a video I saw on YouTube, and I'll put a link to that original video in the notes to this video. So what is it and how does it work? Well, as you see, it's in two parts. Let's look at this part first. So this is a brass rod that goes through just a wooden cylinder. Around the wooden cylinder are stuck 4 solar panels, and the solar panels are wired up to 2 coils that go around the wooden cylinder. So the idea is when light shines on the solar panel, a small current is induced in one of the coils that produces a magnetic field, and as we'll see, that magnetic field reacts with the magnetic field generated by this permanent magnet and causes this whole contraption to turn. As it turns, of course, the light doesn't fall on the original solar panel anymore, but the next solar panel is exposed, and that causes a current to be induced in the other coil, and that produces a magnetic field in the same direction. That's the way they're wired up, and causes it to spin even more, and so on and so on and so on. Now, of course, these are tiny solar panels. They're producing a tiny amount of current and a tiny magnetic field. So with normal bearings, it would never be strong enough to overcome the friction. The clever thing is the way it uses these bearings that are frictionless. The whole contraption levitates because we have these 2 magnets repelling these magnets, and the same on this side. So the only point of contact with the whole thing is just this tiny point, and as you see, I've sharpened the bronze rod that goes through, so it's just a tiny point in contact with this aluminium rod. And so this is the base unit, and these magnets then are spaced very cleverly, no, very precisely, too far apart and the whole thing would fall through, too close together and it becomes too unstable, but at just the right distance the whole thing will levitate. Everything else is built out of aluminium because you don't want it to be magnetic and to then interfere with the magnetic field that's being generated. So in the daytime, if you just put this out in the sun, it'll work and spin very fast even without this magnet, because I think the magnetic field generated by these side magnets is strong enough to interact with what the coil's producing, and the thing just starts spinning on its own. But with artificial light we don't get such a good current, and so we need to introduce that magnet to strengthen the magnetic field. Now, as you see, as I bring this light closer, and it doesn't actually matter which way we help it to spin. Let's just give it a little help in that direction. Then as it comes back, there you see, and very gradually that will build up speed now. And it will build up speed until there comes a time where the impulse, the spinning impulse from the coils, I guess, equals this tiny bit of friction on the end here, and of course the air resistance of the thing rotating. I'll lift the light up now, just see it better, And as you see, with the light further away now, this will continue to spin for a long time. There's basically zero friction. I guess if you put this in a vacuum, it will go pretty well indefinitely. So there it is. I'll show you now what it looks like in the daylight spinning, and until it's going very fast, it's actually quite stable. Without this magnet in the daylight, it'll spin just indefinitely. With the magnet, it begins to spin too fast, and as it's not perfectly balanced, eventually a big enough vibration builds up and it comes off from its bearing. But on the whole, it's very stable. So this is quite fun to sit on my desk and just let it turn around indefinitely.